Very good morning to Dr. Now our Group 6 will present the group projects. Our group have 5 members, which is me, Vijay, as the project managers, and Chelsea, and together manager, and Lucy as the quality control managers, and another 2 members are Wong and Nick Chanjasi.
Good evening to Dr. Ramuzaini. My name is Nick Chandja Singh from Group 6 Instrumentation class, section 7 and 8. So my part of this project is the introduction part. So today I'll be talking about the importance of smoke and gas detection system in modern industries and homes. So as technology advances, ensuring safety is more critical than ever. So smoke detection are essential device that send smoke and as early sign of fire, and many also detect hazardous gas. So they serve as a first line of defense, giving us time to respond and prevent harm. This is especially important in places like factories, chemical plants, warehouse, and high-rise building, where flammable gas and complex system raise the risk of fire. With strictly safer regulations, industry now rely on systems that can be detect even tiny amount of gases like propane, methane, and carbon monoxide. So thanks to the real-time monitoring system, this system quickly alerts us to any problem in our study. We explored how this technology works, the key components like sensors and microcontrollers, and how they help protect lives, property, and keep operation running smoothly. So that's all from me. Thank you.
So without any hesitations, let's start our part with the literature review. For 2.1 is the overview of the smoke of gas detection sensor. In many industry environments such as the manufacture plants, chemical processing facility, and data center, the detections of smoke or gas centration is essential for preventing fire, environment floodings, and hazardous exposures to toxic substances. The use of the automated sensor system enable early warning and real-time monitoring, reducing human error and response time. For 2.2 is the significance of monitoring gas in industry. In sector such as the oil and gas manufacturing, food processing, and HVAC system, the need to measure gas is paramount. Gas sensors ensure the potentially explosive or toxic gases are detected before they reach the dangerous level. For 2.3 is the applications of smoke and gas detection sensor. Uh, for the fire safety system is the first one. For the second one is the environmental monitoring. For the third is the HVAC system. For the fourth is the IoT and smart industry. For 2.4 is the hardware setup for our system. For the first one is the MQ2 gas sensor. The MQ2 gas sensor is an analogy sensor used to detecting the flammable gases such as the LPG, methane, propane, hydrogen, smoke, and alcohol. Uh, the sensor output both analogy and digital signals, making it suitable of gas leaks detections. For the second is the LED lights. The LED light is called that is a emitting diodes, which are as the versions indicators in this system. It ons when harmful gas level are detected and off when the conditions as normal. For the third is the piezo buzzer. Piezo buzzer is an electronic component that produce sound beep using the piezoelectric effects. When voltage is applied, it vibrates and generate a tones. For the four is the Arduino Mega 2516. The Arduino Mega 2516 is a powerful open source microcontroller box built around the ATmega 2516 microcontroller, and is part of the Arduino family, renowned for enable repair photo appliance and developments. For the five is the jumper cable. Jumper cable are insulated wire with connected pins at each ends, used to establish electric connections between components on a blue box or between the modulus and microcontroller box. So the types of the jumper cable is the male to male, female to male, and male to female types. For the last one is the blue box. A blue box is the solderless prototype box that allows user to create a test electronic circuit quickly. So it consider a grid of interconnection source where components and jumper wire can be inserted. So that's all for the literature review.
My name is Uzumela. I will present the system development. First, we will draw out the Arduino Mega and single accuracy cell. As in the diagram, the MQ2 gas sensor VCC will be connected to the 5 volt of the Arduino, and the ground will to the ground, and the log 0 will to the analog 0. And for the pressure model, the positive pin will connected to the Arduino pin 7, and the negative pin will to the ground of the Arduino. And last for the LED, the analog to pin 13 with a resistance 150 ohm. And for the cathode of the LED will be connected to the ground. After that, we will generate the program code for run the program. And next, the stimulation of this circuit using the Tinkercad to stimulation. Uh, as as we know that the Tinkercad does not have Arduino Mega, so we replace it by the Arduino Uno. And when um, the circuit has been completely set up, then we can run to test whether the system can run or not. As we know that the system when it gets injected, then the reading will be remain at the 157, and when the gas are detected, the reading will be go up, so the system can be run smoothly. And next, after the stimulation, you can know that the system can run and the program can run. And finally, the hardware we have set up and go for the next step, calibration. And for the calibration, we have the first stage known as the zero calibration. Um, it is required to placing the sensor in the gas-free environment to identify its baseline output in the absence of the pollutant. Under this condition, the sensor consistently produces the reading in the range of approximately 137 to 139. After that, the span calibration was conducted by exposing the sensor to a known controller concentration of protein gas. During this stage, the sensor output climbed significantly, reaching a value as high as 325. So, in a high protein concentration, this reading was recorded as the surface upper surface point for the gas detection, providing a clear contrast to the baseline measurement.
Hi everyone, I'm Bing Qi, and I will continue to present about our result and discussion for our group project. And for initially, the concentration of gluten for first three measurement, which is 137, 138, and 139, the average value is a 138. And when taken to the 2 seconds, the first measurement is 155, and second is 1060, third is 163, and the average, which is 159.3. And the 4 second is 180, 128, 181, and the average is 181. For 6 seconds, when taken with the 6 second and 8 second, the average concentration of gluten is 249.697 and 324.67. And this is our measurement for the concentration of gluten to move before we move forward to our measurement of the smoke detector. Yeah, thank you. So I will continue to present about the smoke detector, and based on the result and discussion result before, the time taken to release, we setting the concentrated alert is 160, and when the initial reading is 138 and LED status is off and piezo is off also, and when 2 seconds the average reading become 159.3, and but the LED status still off and piezo still off because it's not yet to achieve the value we setting. And for next is 6 second, sorry, the 4 second, the average reading is become 181, and so the LED status is become function, and the piezo also become function. And the LED status will light up, and the piezo have the sound like a beep beep sound to alert the people. And of course, when the 6 second is achieved, the 249.67 average reading for the concentration of protein, and leave the LED status on and the piezo on also. And then lastly, we take the 8 second to reading. The average reading of concentration is 324.67, is almost higher, and so the LED status also still remain function, and the piezo also still remain function to alert the people at the room or industrial. Thank you. So this is our result and discussion for our smoke detector. So thank you everyone.
For the conclusion part, this project developed and simulated a measurement system for gas detector by using elements like MQ2 sensor, Arduino Mega 2560, and piezo buzzer. When gas concentrations exceed the predefined threshold, the system will detect and alert. To avoid oversensitivity, we also make other measurements with high pressure of other gases, such as air, to ensure the gas detector only detects certain gases. So, come to the recommendation part. First recommendation is to incorporate additional sensors like temperature or humidity sensors. Why? Because it can provide a more comprehensive safety monitoring solution. The second recommendation is to implement wireless communication modules like Wi-Fi or Bluetooth, which can be remote and monitoring, especially in large-scale industrial environments. Thirdly, is to have rigorous field testing in real-world scenarios to validate the system performance. So the last two is one is optimized calibration process, and the last one is to explore machine learning, which will elevate the system practically and reliability for industrial applications.
That's all from us. Thank you.